Okay, 0.5, we're going to start reviewing factoring. Okay, factoring is the opposite of multiplying. So if I say that 5 times 3 is 15, that's multiplying. When I say 15 is 5 times 3, that's factoring. So I want to go back and see what I multiplied to get this. Okay, the first method we're going to recall is factoring out the greatest common factor. Okay, so greatest common factor between in the first one, there's two terms. So between the 10x squared and the 15x. Okay, check the coefficient first between 10 and 15. Think of a number that divides out of both of them, and you want to take the biggest possible. Okay, I can't do 10 because 15 doesn't divide by 10. They both divide by 5, so I'm going to pull out a 5. Okay, between x squared and x, they both at least have an x, so I'm going to take out an x. So the greatest common factor is 5x. Okay, I'm factoring it out, so I want to see what I multiply this by to get this. If I were to distribute, if I do 5x times this, it has to give me this. So 5 times 2 gives me 10. I'll put the 2 there. And then x times something gives me x squared. Well, that must be x times x. Bring down the plus sign. To get 15x, 5x times 3 gives me 15x. So this is my answer. I factored out the greatest common factor. Let's look at the next one. If you remember this, you can work ahead. Okay, there's 3 terms on this. So I'm going to check the coefficients first. Between 7, 21, and 14, they all divide by 7. So greatest common factor and for the numbers is 7. Now if I check the variables, x cubed, x squared, x, they all have at least an x. So I'm going to take out an x. Okay, now if I do this times this, I need to get this. 7x times this gives me this, x to 7x to the third. The 7s are fine, x to the third. I need 2 more x's. That must be x to the second. Minus 7 times 3 is 21. X times x is x squared. And then 7x times 2 is 14x. Okay, the greatest common factor was 7x, and then when I factored it out, I got this. Next one's a trinomial. So between 2, 18, and 10, they all divide by 2. How about the x's? X to the 5th, x to the 4th, x to the 3rd. They all have at least x to the 3rd, so I'm going to take out 2x to the 3rd. Okay, to get 2x to the 5th, I need x to the 2nd, plus 2 times 9. X cubed, I need another x. 2 times 5, the x's are good. Okay, let's try one more like this. Okay, 6 and 21. Can I divide them both by 6? No. I can divide them both by 3, so let's take out the 3. For the x's, x to the 7th, x to the 4th, I'm going to take out x to the 4th. Okay, so to get 6, 3 times 2. To get x to the 7th, I need x cubed. To get 21, 3 times 7, x to the 4ths already match. Okay, now let's go ahead and look at factoring x squared plus bx plus c. Now I know some of you made like an x on the side, some of you did different things. How you do it, how you do your scratch work on your side is up to you, as long as you're getting the right answer. Okay, so first let me check. There is no common factor. This doesn't have a coefficient, x squared, 10x, 16, this doesn't have an x. But it is quadratic, so it must factor. So I want to factor into something that looks like this. Because this is an x squared here, this must have been x times x. Okay, now to figure out what 2 numbers go there, and we normally look at the last number, and some of you make a little x, which is fine. Whatever you want to do is fine. But you want to think of things you times to get 16, and I'm going to list them out this first time since this is our first time doing it. For example, if I do 4 times 4, I get 16. If I do 8 times 2, I get 16. If I do 16 times 1, I get 16. All of these are my possible constants to go here and here. The one that is correct is the one that adds up to positive 10. So 4 plus 4 is 8. 8 plus 2 is 10. 16 plus 1 is 17. So this must have been positive 8 and positive 2. And if you do an x on the side, that's fine. If you have a different way of doing it, it's fine. As long as the final answer is x plus 8 times x plus 2, or vice versa. Okay, hopefully that reminded you, and now you can try the next one. If not, let's do it again. Okay, there's no common factor here. This is n squared, so this must be n times n. Okay, now to determine what numbers go there, I need to look at the last term, the C value. Think of what you times to get 10. We don't have to list them out. You can do it in your head, but since we're reviewing, 5 times 2, 10 times 1. Is that it? Okay. Okay, now they have to add up to, -7. So what do we think? Yeah, 5 and 2 add up to 7, but I need them to add up to -7. So I'm going to make it a -5 and a -2. Now they both add up to -7, and when I multiply them, I still get a +10. Okay, and the order of them the two factors doesn't matter as long as you have the -5 and n-5 and n-2. Their signs matter, not their order. Let me keep going. And you can do these in your head. You don't have to list out all the numbers. Okay, let's see. This is a -24. Okay, so I need a positive and a negative. So just be careful with that. So let's see. This is a positive here, so the bigger number is going to take the positive. So 12 times -2. 12 minus 2, is that, no. How about 8 times -3? 8 minus 3 is 5, that's not right. How about 6 times -4? 6 minus 4 is 2. And that's what I have here, 2p. Okay, so this is a +6 and a -4. Let's try one more like this. E squared, E times E. Okay, this is a -45. So it's got to be a positive and a negative. Because this is a minus, the bigger number is going to take the negative sign. So what do we times to get 45? 5 times 9, so -9 times 5. If I do -9 plus 5, oh, I do get -4. Okay, so E minus 9, E plus 5. -9 times 5 is -45. -9 plus 5 is -4. Okay, now let's look at difference of squares. If you recognize difference of squares, they're very easy to factor and you can do it very quickly. Okay, why is this called a difference of squares? Yeah, because this is x squared, and then this is something squared. What do you square to get 64? 8 squared. So that's why it's called a difference. Difference is subtract and you're squaring two numbers. Okay, but when you see that pattern of x squared minus something, you're like, oh, I know it's going to be something like this. This is x, this is x. Since this is a negative here, it's a minus, and it will always be a minus because it's a difference. It's got to be a positive and a negative, or a negative and a positive. And then what do you times to get 64? Well, I do 8 times 8. Okay, now why does this work? Because 8 times -8 is -64. And if I do 8 minus 8, I get nothing or 0. So they cancel. So they'll always cancel. Okay, so if you recognize this x squared minus something, it should always look like this and they should match. Okay, does this have a common factor? 9x squared and 100? Can I divide by 9? No. Can I divide by 3? No. I can't divide by anything, but I would try. So this is probably a difference of squares. Okay, now the question is, what am I squaring to get 9x squared? Well, that must be 3x times 3x. 3x, 3x. It's a -100, so it's got to be a positive and a negative. And then what do you times to get 100? Or square? 10 times 10, which is 10 squared. So 10, 10. Okay, and they're the exact same thing with opposite signs so that the middle term will cancel. Okay, number 4, let's remind you of the zero product property, which some people call ZPP. Okay, if you have a factored form over here and it is equal to 0, you can use the zero product property to solve this equation. This only works if this is factored and it equals 0. It's called why it's called the zero product property. Okay. If this times this equals 0, then it has to be true that either the first thing equals 0, this one, and if I minus 2, I get x equals -2 for one of my answers. Or it must be true that this equals 0. So it's also possible that x minus 5 equals 0. When I solve this, I add 5 to both sides and I get x equals +5. And if you solve that in your head, I'm fine with that. But your answers are x equals -2 and x equals 5. It might just be one, it might be both. So we list all possible. Okay, and again, only works when this equals 0. This one also equals 0. It's in factored form, so it's the same idea. It could be that the first factor equals 0. Oh, I'm going to have to solve this for real. Let me plus the 7 over, and then divide by 2. 7 divided by 2 is a fraction. Good answer. Okay, but it could also be that this factor equals 0, or it could be that both equal 0. Okay, let me subtract the 12, divide by 3, and I get x equals -4 as my second possible answer. Okay, last ones. We're going to do the GCF, and then we're going to factor completely. So we're doing example 1 with example 2. Okay, now you should always check for GCF even if it doesn't tell you to, but this one's giving you a hint. So first GCF. Okay, so let me check. 4, 28, and 40 all divide by, do they divide by 4? They do divide by 4. Let me take out the 4. Do they have any variables? This is x squared. X, this doesn't have an x, so I can't take out any x's. Okay, now if I take out the 4 times x squared is 4x squared. 4 times 7x is 28x. 4 times 10 is 40, which looks good. However, okay, let me bring this down. If you look at this part right here, I'm going to try to factor that more, just like we did before. It does not have a common factor, but it has an x squared, which makes me think it will factor more. Since it's x squared, I'm going to do x times x. Look at the last number. Think of what you times to get 10. You can do it in your head. What are we thinking, 5 times 2 or 10 times 1? And then check to see which one adds up to 7. It's got to be the 5 and the 2, huh? So positive 5 and positive 2. Okay, now this is fully factored. I've gotten them all the way to linear factors. Okay, let's try the next one similarly. Okay, first common factor. Number, oh, this one doesn't even have a coefficient. Oh, technically a 1, but that's useless. So there's no number in common. So let's check the x's. Okay, we've got x to the 5th, x to the 4th, x to the 3rd. They all have x to the 3rd, so I'm going to take out x to the 3rd. If I take out x to the 3rd, this goes down to x to the 2nd. 6, this goes down to x. This goes down to 7. Okay, now just like the last one, since this is x squared, I'm going to try to factor it more. It does not always factor more, but I can always try. Factor. Since it's x squared, I'm going to do x times x. Okay, now what do I times to get -7? Well, it's either 7 times -1 or -7 times 1. It has to add up to +6, so the bigger number's got to take the positive. So +7 minus 1. 7 minus 1 is 6. That works. Okay, and that's a good factor. Let's try the next one. 3, 33, and 90. Do they all divide by 3? Yes. Okay, now can I take out any x's? X cubed, x squared, and x. They all have an x, so let's take out an x. Okay, 3x, I need x squared. 3 times 11, I need another x. 3 times 30, and I'm good. Okay, again, the trinomial has a squared, so I'm going to try to factor it more. X squared, x times x. Look at the 30. See how many times you get 30. Let's see, 3 times 10, that doesn't add up to 11. 15 times 2, 5 times 6. Oh, it's got to be 5 and 6, huh? But it's a -11, so -5 minus 6. Okay, one more. 8x squared minus 50, common factor. Could they divide by 8? No. How about 4? No. Let's go smaller. How about 2? Let's take out a 2. 2 times 4 gives me 8x squared. 2 times 25 gives me 50. Okay, let's try it now. Okay, now inside the parentheses, there's still an x squared, which means I should at least try to factor it. Okay, now this one's a little bit weird because it's a 4x squared, but it looks like a difference of squares. So what do you square to get 4x squared? Or what do you times by itself? 2x times 2x. Okay, and then I have this negative 25. So plus, minus, and then to get 25, right, 5 times 5. It's a good factor.